Hi, this is Cyprien from FE for All, and welcome in this new video tutorial for Salome Meca, in which I will talk about contact between plate and solid. So in one of my previous videos I'm talking about how to assign a contact between two solids, but I realized that it's not exactly the same than the contact between a solid and a plate, for example. There are some subtleties and differences, so I decided to make a separate video about it. And so let's start. Let's create a simple geometry, and what I'll do is to create a plate. So let's create a simple rectangular face like this one. Okay, close that, and let's just create a small cube on it, and I will create a contact between this cube and this plate. So let's go into that, and let's create. So for the dimension, let's use 20, 20, 20. So the cube is small enough. Okay, now that I have those two things, some important thing to do on the geometry is that I need to create the intersection of the cube and the plate. So I need to have some kind of imprint. So in all the software, it's generally called imprint. So how do we do that? Well, the way I found was to use the option called partition. So let's try that. So I may need to create a wire of the face or something, but I'm not sure. So let's just try. So this is the face. Let's select the tool object, which will be the box, and I want a resulting wire object on the face, no subject intersection, apply and close, and let's see what we have. Okay, I think it worked. So now I got a plate with, okay, just one thing, I have the feeling I got a wire because I checked wire, right? When I wanted to have a face. So maybe I have to delete this one and just do it again, because I want a face, so I don't want a wire. Okay, that's okay. Object, okay, the face, select the box, no, face, okay, and the box, okay, and I want a resulting type as a face. Okay, so now we have a partition with the imprinted face of the box on it. So that will be our second part. So I can just delete my first face, I won't need it. Yes, okay. Okay, I deleted that, and now it seems that there's an invalid reference, so maybe I shouldn't have deleted that. Okay, so I didn't know. Okay, and so the problem that you can't come back. So let's do that again. Okay. So I'm voluntarily leaving this part in this video because I hope that some developers will eventually look at it. So okay, partition, face, tool object, box. Okay, I start to remember how to do those things. Okay, so I don't delete the face this time. Okay, I got that. So the next step is to create the groups. So let's go into new entity, group, create groups, and let's see what we need. So we need some kind of edge group of the edges of this. So because what I'll do is that I'll constrain those edges. I just constrain those edges. So this will be face edges. Okay, make sure don't leave a blank in the names, otherwise it will cause some problem. Okay, afterwards. Okay, I got this. Now I need now to create some group faces. So let's select. So let's select the sub mesh here only at the beginning, and let's call that contact 1. That's what the face will use for the contact. And I need also a group for all the plates, so both surfaces, this one and this one. So I got the two, and this will be plate. Okay, plate face, I can call it. Apply. And I think that's probably okay for this. Now let's switch to the box. Okay, let's show up the box, and let's. Oh, I cannot hide the plate like that, so I have to close that. Okay, hide the plate and open it again. Okay, create group. Okay, so for the box I will need one surface. I don't know why it chose the plate again. I think because I chose it as a main shape, that's why. Okay, so let's close that. Let's hide it. Let's select the box. Okay, let's create group. Okay. Let's select the top face, and let's call it top face, right? Always better to choose names which are kind of explicit. Okay, now let's turn the box. Let's assign a group at the bottom. So let's call it contact 2, because that will be second face in contact. Apply. And I will need probably a group for the whole box. So just select the volume here. Let's call it box. Apply. And there's one thing I forgot, is that the slave will be the nodes from the plate, right? So I need to create. So if you watch the previous video on contact, you know that I will need to select nodes for the slave face. So let's do that. Let's show that again. Ah, okay. Yeah, I'll do that for the mesh, not for the geometry. Yes. Okay, so the groups here are constructed, so that's okay. Now let's switch to the mesh. Okay, let's save your project, and now we have to create mesh sets both for the plate and for the box. So let's select the partition of the face first. Let's click on create mesh. Let's select the algorithm. I'll use this one. I can put a name like plate mesh to be explicit. Hypothesis. So for the hypothesis, let's just use what I have here. And what I want to do, let's display the plate. What I want to do is to refine the mesh around this, right? So how do we do that? Well, I can do it using onFace, and you see it automatically. Okay, it shows the whole partition actually. So this is not what I want. So let's click on contact 1. So I want contact 1 on face, and I don't know how to delete. Oh, okay, there is a remove. Okay, so now there is I can define the size of the mesh on this contact area, right? So let's just choose a small size, like 2 for example, because as I said in the previous video, and this was correct, the mesh size on the slave face must be smaller than on the master face. Okay, and apply and close. Let's just mesh to see what we get. Okay, so that's what I wanted. So I got my plate, and this is refined in the area around the box. Now let's mesh the box, right? So let's select the box. Let's create a new mesh, and let's call it box mesh. Hypothesis, well, let's create a new one. Well, it's not a new one, but okay. Okay, moderate, that's it. Okay, and I want also, okay, let's display the box, right? Let's display the box and let's hide everything else. Oh, it doesn't want to hide the mesh. Okay, so I have to close that. Hide the mesh and select the box again and create a new mesh and do all those steps again. Okay, yep, local size. Now select the contact 2 area here and on face, and here let's say I can use a size slightly bigger, but I prefer to have the same size. So let's use 2 as a size for the box. Apply and close. Okay, now I can mesh the box. Oh, I forgot to change the name, so let's call it box mesh. Okay, and let's compute that. Okay, and you see that the mesh is slightly smaller on this face. And now I got both. So I got the 2 mesh sets, which is great. Okay, let's save. Now I need to create the groups for the mesh, right? So mesh, create groups from geometry. Let's create for the plate first. So let's select the groups that I have here first, and then for the nodes I only need the nodes on the contact. So let's do like that. Apply, and you see that I get group of faces, group of edges, and group of nodes, which is fine. Now let's select the box mesh, and here let's select the geometry groups here, and that's all we need, and that's it. So I got my groups for both mesh sets. Now let's go to Aster Study. So this is where I'm going to show you how to really set up the analysis, because now it was really just modeling phase. So add a stage. So now we have 2 mesh sets again, so let's read those 2 mesh sets. Plate mesh, so let's call it also plate mesh to be consistent. So okay, it only allows limited number of characters, so let's call it p mesh. Okay, p mesh. And the second one, read mesh, let's call it b mesh, right? Now let's create a mesh to assemble those 2 together. So b mesh and p mesh, and here for the operation, as I mentioned in the previous tutorial, I'll use superpose. So I can repeat the reason. The reason is that the first collage means joining, and you need to have exactly the same elements and nodes at the interface, otherwise you cannot use this option. So you need to use superpose and then define a contact. That's what we will do. So click on OK, and let's call this one just mesh. So this will represent all the mesh of my model. And now the next step, well, there's still one thing I need to do. So as I have, let me think about that. Okay, no, maybe I don't need that. Okay, I need to create a model. So let's, but before I create a model, I need to assign some kind of property to the plate, because this is a 2D element, so I need to Oh, I don't know what it did. Come back to us to study. I think it's, I don't know, it closed the panel somehow. Okay, okay, I clicked on the view here. Okay, so let's create, okay, I need a model in order to define this. So as I need a model, I have to create the model first. So let's delete that for the moment. Let's go into model, and here let's select the whole mesh set, and there's some trick that actually I didn't understand for the first time, because I always used only solid. So you have the possibility to define two types of mesh, different kind of mesh in one model. So how do we do that? Well, basically, well, you have to first, so this is the box mesh, select that. I'll show you. Modelization 3D. Okay, and you see here that you can add a second type of model. Yeah, that's the trick. So now you can select plate and plate face, and now you're able to assign a plate property to this as well. So let's use a DKT element, which is for shell elements. Okay, that's done. Okay, I have my model, so now I can define the char element, in which will detain the characteristic of my my surface, my 2D mesh here. So for that I have to use the coq element. Coq in French means shell, so this is shell element, group of elements. So now let's select the plate. Okay, let's give it a thickness. So épaisse means épaisseur in French, so it means thickness. So that's it, 0.01, and okay, that's all I need, I guess. Now let's see if I need something more in this. I don't think so. Now I need a material as well, so let's define a material. Okay, let's use 200,000 and 0.3, so I can call it steel if I want. Okay, and let's assign that. So I can assign that directly to the model here. Okay, everywhere. Okay, so everything is fine. Click on OK. Now I have my material. So the next thing to do is just to assign the boundary conditions to all of that. So let's start with assign mechanical load, and here you have to display the model. So it's okay, I have my model. So let's fix the plate, enforce degree of freedom, edit. Let's select group of elements, and here plate mesh, select the face edges. Okay, and let's fix all the degrees of freedom. So as this is a plate, it has 5 degrees of freedom per node, so we have to fix all that. And now let's define Well, in previous videos I always define a pressure. Let's change. What can I use this time? Displacement maybe, why not? So what should I use as a displacement? Displacement should be okay, this one I think, face impo. I can impose a displacement on a certain face. Group of elements. Let's select the box, top face, okay, and let's put a displacement in minus z, so 0 point, or let's use a unit displacement of 1, and okay, and let's define the contact in a separate case. So now it's time to define the contact between the plate and the box. So let's go again in assign mechanical load, where you can define that. And so the contact keyword is this one, liaison mail. So it means connection mesh, basically, in French. So that's where you define that. So in the previous tutorial I use massive, which means volumic or something. So because I had two volume, now I have a plate and a volume, so I need to use either this one or that one. So the difference being that the slave and the master are not the same. So if I want to change the slave or the master, I just have to change it here. So let's use this, and basically I need to define a master group of nodes. So this should be a volumic type of elements. So this is it. And here, as I talked about in a previous video, if you define it as group mesh slave, all the mesh in which are linked to this will be fixed. So in this case, maybe I could use that actually, just to fix the contact surface, because it's not a solid, right? But I prefer to use the second one, group node slave, because I'm sure it will work. So let's define, and here I have to define the nodes on this. Now I have to define the thickness of this area here. So if I remember well, I use 0.01 as the thickness. And now there's a small problem, right? I need this champ normal. What is that? What is this champ normal? So in order to understand how it works, there's only one solution, because nothing is explained here. I need to go to documentation. So I already downloaded the documentation, so you can find it on Google. So this is the documentation for the operator Salome Meca, and I have to go into the keyword liaison mail. So let's go down and let's search what the hell is the champ normal. Okay, champ normal, I have it here. It means these two keywords are obligatory. Okay, so basically it indicates the normal to the contact. Okay, so it seems to be using this kind of function that I can create this. So I need to create a crea champ and input those options for it to work. So let's do that. So let's temporarily say okay, invalid input because I don't have champ normal, I know. Let's click on OK for the moment. Okay, let's just change the name, let's call it contact. Okay, and now I need crea champ. So where is this création? It's okay, if I remember well, it's in post-processing, so création is here. And okay, also création means create field, right? So it will create a field. Okay, and how to define that? So let's call it like this, CHORNOR, and type change must be neugium-R. Okay, so let's search that. A lot of options here. Neugium, where is it? Okay, it's here. Neugium, and the operator must be normal, model, and do I need something more? No. Oh yeah, the group of elements. So here I need to give it the actual group, which is the contact one face. Maybe I can give it the full plate. I can give it, I think, the full plate. Okay. Okay, now that I have that, let's come back to contact. And let's edit this, and you see that this information has been filled, so you click on OK, and now your function definition is valid. And you see, by the way, that the order changed, so it already went automatically up the contact, so this is defined before that, because there is a certain order in the definition of the function in Codaster. Okay. So now that I have all of that, I think that I am settled for the analysis. So the only thing I remain to do is to create the static mechanical analysis. Let's define the material field and the structural elements, the model. Let's associate the loads. Okay. And the contact. And let's click on OK. Let's add the stress calculation. So I should call it also with the same name, Wrestling, right? And as you remember, probably the stress is here. Contrainte means stress in French. And this is sigma L no, which means stress in the element nodes. Okay. And finally, let's output that. Set the output results to, okay, let's call it study1.rmed, which is the format to output the results. So, and here I need to associate those results with it. Save that, and now it's time to launch the analysis, right? So let's hope that it will work. Maybe I can increase a bit the memory, don't know. Okay, please solve me that. Okay, it doesn't work, so there's problem somewhere. It rarely works from the first time, right? So let's go down and let's see what it tells me. The name, so it's in French, but it tells me the name contains forbidden characters. Okay, I never got this error before. So I know you cannot use the okay, this. So now let's, okay, that will be a bit cumbersome. Basically what I have to do is to come back here, change the name of the groups, and to update my Aster study. Okay, that's really Okay, oh, I shouldn't have called it like that. So let's just remove, you know, this sign. I don't know why they cannot do a reader which will simply ignore that, but anyway, I'm not a developer. Okay, let's go back to as the study, and now I need to search for the places where this group is used inside here. Okay, so here I have a group MA which is using this, so this is probably here. So I have to delete it here in the manual selection, and then I have to associate that again. Oh, better, maybe I have a better idea. Let's convert that to text mode, and let's edit directly the text. Sometimes it's faster, and maybe I can even search for what is. Let's just remove this like that directly into the command file. Okay, top face here. This one is okay. I think it's all really. So now let's convert that again to graphical mode, and it works again. Okay, now let's try to launch again the analysis. Run. And this time I hope it will solve that. Yes, I'm getting the green one. This is a good news, guys. Let's open that in Paravis. And let's take a look at those results. And I hope I'm getting something good. Okay, so this is my model. I have no displacement here, so I have to activate that here to be able to. Yes, that's nice. Nice. The cube is pushing. I'm getting 1 millimeter in 1 millimeter in maximum displacement, which is pretty okay. Let's show the deformed shape just to see how it looks. Generate vector. Filter common warp by vector. Okay, it's actually going down. Let's increase the scale a bit. Okay, so that's nice. I have my contact. I have. Let's look at the stresses to see what we have here. So stresses generally require much better mesh. So I'm not sure I have a good enough mesh for this kind of to get some kind of accurate result for that. But let's take a look anyway. Sigma Alno. Oh, this is a bit strange. Okay, so it seems that no, well, maybe it's not. There are a lot of areas which don't seem very accurate, but anyway, I'll have to take a look on that. Probably because the mesh is not good enough for that case. Okay, so that's all for this tutorial. I hope you learned a lot, and thank you again for watching. If you like this kind of tutorial, if there's something special you want to see or learn to do with Codaster, leave a comment either on the blog or on in the comments in the video, and you're very welcome to let me know what you think, even if you see something to improve to this process, or if you If you see something to add, don't hesitate to leave a comment. Thank you very much, and see you on the blog.